In this experiment, we're going to learn how to make hot ice. So we're going to take sodium bicarbonate, which is baking soda, and acetic acid, which is vinegar, and make carbonic acid and sodium acetate. We have our sodium ion, which is the gray one. We have our oxygens, which are red. We have our hydrogens, which are white, and we have our carbons, which are black. We also have a bunch of single bonds and 2 double bonds for this reaction. So I'm going to start off with making the sodium bicarbonate atom molecule. So we're going to start off with taking our carbon, which is our central atom, and a carbon has four shells where we can place electrons. So I'm going to double bond the carbon to one oxygen, and then I'm going to single bond it to 2 other oxygens. The double bond takes up 2 electron shells, and then the single bonds each take up 1, which end up filling the 4 shells in carbon. On these oxygens, the double bonded oxygen doesn't get anything, but the 2 single bonded oxygens, on one of them, we're going to add a hydrogen. This makes an alcohol group, an OH group. And then on the other single bonded oxygen, we're going to add a sodium. So we have the sodium, and this is our sodium bicarbonate. I'm going to put this aside for now. And then we're going to use the rest of the molecules to make the acetic acid. So again, we're going to start off with our carbon. 3 of its shells are going to be filled, shells are going to be filled with hydrogen. So I'm going to add 3 single bonds. Hydrogen can only single bond in atoms. Hydrogen only has 1 shell available, so it can only form single bonds. Now that I've single bonded 3 hydrogens, we still have 1 space in carbon to add something. So we're going to add another carbon. We're going to add another carbon to this. And this carbon has 1 single bond to the other carbon and 3 more spots. So I'm going to use 2 of those spots to add a double bond and add an oxygen onto here. And in the last spot, I am single bonding an oxygen. So now our carbon is full. We have 2 electron groups in the double bond, and then 1 each in each single bond. This oxygen still has space, so we're going to add a single bonded H to make another alcohol group right here. So this is our acetic acid. When we do this reaction, it's called a displacement reaction. We're going to displace the sodium ion from here. We're going to take the sodium off of the sodium bicarbonate, and we're going to take the hydrogen on the single bonded oxygen off of the acetic acid, and we're just going to switch them. So we're going to put the sodium where the hydrogen used to be, and the hydrogen where the sodium used to be, and now we've made carbonic acid and sodium acetate. We're going to combine baking soda and vinegar. So I'm going to start by pouring the vinegar into my glass. And if you guys don't want to make a mess, you should also use a tub at home to put this in. We're going to see the reaction between sodium bicarbonate, which is the baking soda, and the acetic acid, which is the vinegar. And here. It's going to bubble a lot. The bubbling is from the unstable carbonic acid decomposing into water and carbon dioxide. Once the bubbling stops, sodium acetate will be present. So right now. But it's very diluted by the water that is in the diluted vinegar already. So we boil the water and sodium acetate solution, which I'm not doing right now, but when we boil it, you're going to boil out all the water, and what's remaining is a concentrated sodium acetate solution, which is going to appear really cloudy, unlike the clear one we have in the cup. If you pour the concentrated sodium acetate solution onto a plate, It will appear to be solid ice, but warm to the touch due to it being exothermic.